There are 4 key facts about any IP subnet. In this video, I'll show you how to calculate those using binary math. But you can also find those facts using decimal math. So this video shows the binary method. The next video, which you should watch immediately afterward, shows you the decimal math, and then you make a choice. Which do you want to get good at? And then practice that one. All right, let's talk about how to find those answers with binary math. For those of you that have the books and are following along, the current edition, Volume 1, Chapter 14 is where the equivalent content resides, and that chapter has these 3 sections. So this video is the middle of those, or at least this video covers that same content. So that first section defines those 4 key facts about any subnet. And this middle section shows how to calculate those in binary, and the third section shows how to calculate those with decimal math. So here in this video, we'll talk about decimal to binary conversion for a bit to get started, but we'll focus on the subnetting processes that use that binary math. First, the subnetting process to calculate probably the most important of those 4 facts, which is finding the subnet ID. And then we'll talk about the subnetting processes to calculate the subnet broadcast address. Those are important because those bracket the numbers in a subnet. And then it's really easy to calculate the range of usable addresses in the subnet. We'll close out with a shortcut that'll really speed you up when you're doing the binary math. Stick around to the end for the usual kinds of advice, except it's not the usual kinds of advice. I'm going to get to the end and say, now go watch the video about doing the same thing with decimal math so you can choose. Do you want to pursue and practice using the binary method or the decimal method? All right, let's talk about the binary method. The first thing you need to learn, or relearn as the case will be for many of you, is how to do basic decimal to binary and binary to decimal conversion. So for instance, consider this IP address 10.123.219.1. You need to be able to convert each of these decimal numbers to its 8-bit binary equivalent. Why 8-bit? Because each octet represents 8 bits. For instance, here's the converted number. So 10, it converts to 1010 if you ignore the fact that we need to represent 8 bits, but because it converts to an 8-bit number, you have to put these leading zeros to fill up the 8-bit positions, all right? So convert 10 to its 8-bit binary equivalent, 00001010. 123 converts to this, 219 converts to this, 1, decimal 1, converts to 7 zeros and a 1. So by doing this conversion, we now have on the screen a 32-bit binary number, which we know IP version 4 addresses are 32-bit numbers. The subnetting processes then will change that binary number. For instance, maybe it changes the last several bits, like you see here, the last 12 bits have been changed to all zeros, or at least they're now all zeros. So once that process is done, you need to convert the binary value back to decimal. Get this. Every time you convert a 32-bit IP version 4 address back to its decimal equivalent, it's always on the octet boundary. It's always 8 bits at a time. So that's why I've written the number with these dots between them to make sure you remember the octet boundaries. So these 8 bits convert to 10, these 8 convert to 123, these 8 convert to 208, and these 8 convert to decimal 0. All right, so that's the skill you need to be good at for the base math, which is taking 10 and getting this, taking this and getting 10, taking 219 and getting this, taking this and getting 208. All right, so how do you do that? Well, for many of you, that's relearning, but even if it's brand new learning for you, that's the math you need to do. There's a link to a good video to use in the description for you to learn that. I am not teaching you that base math here in this video. I'm teaching you how to do subnetting processes that assume you can do that math, all right? There's tons of videos out there on the internet and on YouTube even here to teach you that math. Once you've got the basic idea of that, you should practice and get good at that math. And the good news there is Cisco has a tool called the Cisco Binary Game. There's a link to that in the description as well. You can also Google that and find that pretty easily. It is a fantastic learning tool. It lets you practice conversions in both directions. It's very good at teaching you the process. So if you're thinking, hey, I learned how to do this before, I just don't remember it, just crank up the Cisco binary game, and that may be all you need to refresh your mind on how to do this. And once you get good at doing the binary conversions, you'll want to watch this video and learn what the processes are, but then you should practice, of course. Any and all subnetting practice problems can be used to that end, and then you can check your work. But I'll point out one tool in particular. There's a tool called calculator.net. It's a site with lots of different kinds of calculators. They have a subnetting calculator there. And the one thing that's nice about that one is that it shows the binary version of the IP address and the binary version of the mask, the binary version of the subnet ID, and so on, so you can see your work if you're working in binary. By the way, when you are thinking about buying my books, any other books, or anything else for that matter, if you'll start with this QR code or my link tree and buy from there, you don't have to pay anything more, but those sellers will give me a small affiliate marketing credit. It's a great way to say thanks and support the channel. All right, let's get back to the content. So let's review. What are the facts that we're looking for? Well, first there's the subnet ID, which is the lowest number in the subnet. It represents the subnet. It cannot be used as an address by any host in the subnet. Then similarly, the subnet broadcast address cannot be used as an address either. It's the other reserved number. What's its purpose? You can send packets to the subnet broadcast address, and all the hosts in the subnet should consider replying to those. For instance, you can ping the subnet broadcast address, and many hosts may reply to that. All right. It's numerically the highest number in the subnet. So by knowing the subnet ID and subnet broadcast address, you know the high and low values in the subnet. They happen to be reserved for use. Then to find the first and last address, the numerically lowest and numerically highest usable addresses, it's easy because the first address is just one bigger than the subnet ID and the last address is just one less than the subnet broadcast address. All right. So just for a little context, say you've got a network design, you've got this topology diagram, you've got a LAN, one VLAN off of router R1, and you've got some hosts in there. And say, here's your subnet ID and mask. And maybe you've got some addresses like 10.111, 112, etc. through 114. Then generically, you can think of the four facts like this. Here's the subnet ID, which we'll show how to calculate here in binary in just a second. Here's the first address, whose fourth octet is one bigger. Here's the subnet broadcast address that happens to end in 255. And the last, or the numerically highest usable address, right above it here, ends in .254, one less. Next, let me tell you about the individual things you'll do inside the process to find these answers, and then I'll show you 3 examples of the entire process, all right? So the first thing you're going to do is you're going to start with an IP address and its mask, and then find those 4 facts. So you're going to want to convert your IP address to its binary equivalent. No surprise there probably, so in each case you take each octet and convert it to its binary equivalent with those skills that you just learned and refreshed. Then you take the mask, whether it's in prefix notation or dotted decimal notation, and you convert that to its binary equivalent. Now, I've got earlier videos about how to do that quickly, so whether you use your newfound binary and decimal conversion skills or those earlier tricks, either way, you'd come up with this as the binary version of the mask. You need to perform some Boolean math on those two 32-bit binary numbers. And that Boolean math is called a bitwise Boolean AND. So first let me define Boolean AND, and then I'll define the bitwise part of that. So with the Boolean AND, you take any 2 bits and you apply an AND operation to them. And here's the table that shows you the results. If the 2 bits are 0 and 0, the answer is 0, 0 and 1, 0, 1 and 0, 0. The only combination that gives you a 1 as the answer is 1 and 1 gives you a 1. So 2 inputs, 2 bits as input. This final option gives you a 1 as the result. So a bitwise Boolean AND is where you take long strings of binary numbers of the same length and apply that logic to each bit position. So bit position 1, bit position 2, bit position 3. For instance, let's just say I've got 2 4-digit binary numbers like these, and I write them above and below each other. So in this case, if I consider the first bit position, 0 and 0 yields a 0. Second bit position, 0 and 1 yields a 0. Third bit position, 1 and 0 yields a 0. 1 and 1, of course, that yields a 1, applying that Boolean AND logic. Of course, in this case, I'm going to do that with 32-bit positions because the numbers are 32 bits long. So finally, let's talk about an example of the entire process. We'll have this IP address with this mask, and you start with the converted binary IP address and the converted binary mask. All right, so I've assumed you've already done those conversions, and you want to write those above and below each other. It doesn't really matter which one's on top, right? You're going to get the same answer. And we're going to do this bitwise Boolean AND of these numbers. And here's the result. 1 and 0 is 0, 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 1 and 1 is 1, 1 and 0 is 0, 1 and 1 is 1, 1 and 0 is 0. And no, I'm not going to do that for the next 24 bits. You can do that as an exercise. Hit pause if you'd like to check it out. And that 32-bit number is your 32-bit binary subnet ID. So yes, if you take the IP address and mask and do a bitwise Boolean AND of those two numbers, you get the subnet ID. Simple enough, right? Then you've just got to convert it back to a more convenient form like a dotted decimal number. So whenever you convert from binary back to decimal, you do it 8 bits at a time, which is why I leave these decimal points here in between each set of 8 bits. As a reminder, conversions happen 8 bits at a time. So that converts to 10, to 12, to 14, and to 0. There's your dotted decimal subnet ID. So what's the process? Well, your first step in the process is to convert the mask and address to binary. And when you convert those, it's nice to write and arrange those values above and below each other, column aligned, so you can line the bits up to make your choice of what is, bit and bit equals whatever, right? Then to find the binary subnet ID, you perform that bitwise Boolean AND of the two 32-bit numbers, and to find the dotted decimal version of it, you convert it back to decimal. So just to drive it home, let's do 2 more examples. Here it's 10, 54, 87, 25 with a little different mask with a 252 in the third octet. So if we take that IP address and we convert it to binary, and we take this dotted decimal mask and show its binary value here. Notice it's got 6 ones and 2 zeros in that third octet. Take those two numbers and do our bitwise Boolean AND. 0 and 1 is 0, 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 1 and 1 is 1, and so on. We get to this value as the subnet ID. And again, I keep these periods in between here, in between the octets, as a reminder that when you go from binary back to decimal, that process always happens 8 bits at a time. So this conversion process gives us a 10.54.84.0 as the subnet ID. One more, 10.89.95.71 with yet again a different mask. Do the conversion of the IP address to binary. Convert the mask to binary. Notice the mask has 2 ones in the fourth octet with 6 zeros. Do the Boolean AND you get to this value. Convert those 1 octet at a time back to decimal. You get 10.89.95.64 for the subnet ID. Finding the subnet broadcast address follows a process that requires converting things to binary and converting them back to decimal, but it has a few differences, of course. One difference is that you invert the subnet mask before doing any of the Boolean math. And then when you do the Boolean math, instead of a bitwise Boolean AND, you do a bitwise Boolean OR. But otherwise, the process kind of follows the same thing that it did to find the subnet ID. So let's talk about those differences for a moment. First off, Boolean OR, you take a bit, OR it with another bit, and you get a result. So 0 or 0 gives you a 0. Every other combination gives you a 1. So basically, the logic is if at least one of the 2 bits is a 1, the answer is a 1. So a bitwise Boolean OR is you take 2 same length binary numbers, and you take each bit position and apply an OR to them, and the answer is another binary number of the same length. So for instance, in this case, 0 or 0 gives you a 0, but the other 3 bit positions have at least one 1 in them, so you get an answer of 1 in each of those other bit positions. So we're going to apply that Boolean OR logic bitwise to those two 32-bit numbers when finding the subnet broadcast address. That other operation I mentioned was called inverting a number or inverting a mask. So for a single bit, inverting is 0 becomes a 1 and 1 becomes a 0. You just flip the bit to the other position. So on a 32-bit number like this binary subnet mask, inverting it, you just swap the bits to the opposite one. So all the 1s become 0s, all the 0s become 1s, and there's your inverted mask. So I'm going to do 3 examples, and it's the same numbers as we had in the 3 examples for finding the subnet ID. So here's 10, 12, 14, 19 with a mask of 3 255s and a 0. So there's the binary version of the address. Up top in gray is the binary version of the mask, but we want to invert that. So there's the inverted version of the mask, and it's that inverted version of the mask that we'll use to do the bitwise Boolean OR. So we apply that bitwise Boolean OR and get this value. And I'm going to show you examples of the Boolean OR out here in the 4th octet. 1 or 0 is 1, 1 or 0 is 1, 1 or 0 is 1, and so on. And it turns out, since you've got all 1s there in the 4th octet of that inverted mask, you end up with all 1s down here, and that's part of the effect of what happens in this operation. So there's your broadcast address in binary, and as always, converting from binary back to decimal, we do it an octet at a time, right? Never 7 bits or 9 bits or 10 bits at a time, always 8 bits at a time. That's why I keep these decimal points in here to mark the octet boundaries. So converting these back to decimal, we get 10.12.14.255. For the next example, here's the 10.54.87.25 IP address. We convert that to its binary equivalent. I'm not going to show you the binary version of the mask, but immediately show you the inverted version of the mask. I'll leave it up to you to figure out the binary version of the mask. So there's the inverted mask, and we're going to do a bitwise Boolean OR of these two numbers, and we get this. Notice those bunch of 1s here at the end because of that effect. That gives us the broadcast address in binary. We convert it to decimal and get 10.54.87.255 for the broadcast address. One more, you see the address in mask at the top. Here's the IP address in dotted decimal. There it is in binary. There's the inverted mask. So the subnet mask is 26 1s and 6 0s. Now we've got 26 0s and 6 1s in the inverted mask. We do the bitwise Boolean OR of these two numbers, and we get this answer as the broadcast address converted back to dotted decimal. We get 10.89.95. Finding the range of usable addresses, that is, addresses you can assign to hosts to use in a subnet, is very simple and requires no binary mask. The first address, you just add 1 to the 4th octet of the subnet ID, and for the last usable, subtract 1 from the 4th octet of the broadcast address. Easy enough. So to drive that home, here's an answer table for example 1. There's the subnet ID. So what's that first usable address going to be? The same thing, just 1 bigger in the 4th octet. How about the last usable? Here's the subnet broadcast address, but 1 less than the subnet broadcast address for this last usable address. Example 2, here's the answer table. There's the subnet ID, 84.0 at the end, so 84.1 for the first usable address. And over here, the subnet broadcast address ends in 87.255, the last usable 87.254, 1 less in the 4th octet. Example 3, just to be complete, here's the answer for the subnet ID, ends in .64, so the first usable ends in .65, and you guessed it, the subnet broadcast address ends in .127, so the last usable address ends in .126. There's a shortcut to the binary process so that at most you have to do binary in only 1 octet instead of all 4. That's a nice shortcut, right? So here's the idea. You work octet by octet, and you key on the dotted decimal masks values. So if you're looking, say, to figure out the subnet ID, if the mask is 255 in an octet, it turns out the subnet ID is equal to the address. So you copy the address's decimal value. And if the mask's value in an octet is 0, it turns out the subnet ID is going to end up being a 0. So you write down a 0. So if you go through that process, you're going to end up with either the answer or most of the answer with one octet missing. And then I'll show you how to find the rest of the answer. Now for the subnet broadcast address, it's a similar process. You key on the value of the mask. The mask is 255. You copy the address's value. But if the mask is a 0, it turns out the subnet broadcast address is going to have a value of 255 in that octet. So that's the logic. And if you have an octet that's empty, we're going to do the binary process in that octet. So let me show you some examples just to find the subnet ID. I'll leave it to you to then extrapolate it and figure out how to find the broadcast address. So here's that familiar example 1 with that easy mask. So notice all the mask octets are either 255 or 0. So we're going to find the subnet ID with this shortcut process without having to do any binary. So what are the rules? It says, hey, if the mask is 255, copy the address octet. So we're going to copy 10, 12, and 14 down below. And the other rule was if the mask is 0, write a 0 and you're done without any binary math. Nice, huh? So when you've got a nice easy mask like this of all 255s and 0s, you can quickly find the subnet ID. However, example 2, we have a mask that has one octet that's neither a 255 nor a 0. So this third octet is going to require some binary math, all right? But just to show the process, the first 2 mask octets have a 255. So we copy those decimal values from the address down below. We've got one octet where the mask is 0, so we write a 0 in the subnet ID down below. But lo and behold, this third octet is empty. We've got to figure out what to do. So we convert the 87 decimal to binary. So we've converted the address to its binary equivalent for just one octet. And we convert the mask to its binary equivalent for just one octet. Do a bitwise Boolean AND of the 2 numbers to get this. Convert it back to decimal and get an 84. Now you've reduced the amount of decimal to binary, binary to decimal work that you had to do. And just to be complete, the third example, same kind of thing. We've got 3 octets where the mask is 255. So we can copy the address's value for all 3 of those octets down below. We don't have any mask octets that are 0, so we can't use that. And we're left with this 4th octet where we're going to have to do the binary math. So 71 converted to binary here. The mask 192 converted to binary there. Bitwise Boolean AND gives us that, which gives us a .64 in the 4th octet for the subnet ID. All right, study group, here we are in chapter 14 in the book, chapter 14 in the course, if you will. And we're talking about the binary process to analyze subnets and find those 4 key facts. Your next step, go watch the next video and see how to find the same facts with decimal math. Then once you've seen that, you can think about, do you want to figure out how to do that? Do you want to practice? Do you want to get good? Do you want to get fast for the exam using the binary process or the decimal process? And then practice that one. All right, but you shouldn't be practicing both. In fact, if you hear of other ways to use binary or decimal shortcuts to find the answer, you should, and you like those better, use that. But pick a way and practice that and get good at it and use that on the exam, all right? So practice. I've got a video here at the channel that lists all the subnetting tools, so you can watch that. It should be in a link that shows up over my head right now. Just to mention a few of them in the books, if you have those. At the end of this corresponding chapter, there's more practice on finding key subnet facts. There's an interactive version of those same questions or actually different questions on the companion website for the book. My blog has more practice questions. I've got a whole product of practice questions with 200 practice questions of this type in the practice questions kit. It's also talked about in that video over there. use the Cisco binary game to get good at the binary to decimal conversions. And there's even that calculator.net subnet calculator that I mentioned that reinforces that binary conversion and shows you that part of the answer if you want to check that out. But definitely you want to watch the video about how to do this in decimal so you can make your decision about which style that you want to use. So I've mentioned it enough, right? But on the left, click there to get to the next video, Finding 4 Key Subnet Facts with Decimal Math. If you want to get that video about how to practice subnetting, watch that video and learn about those various tools. Click over on the right. Thanks for spending time. I'll see you in the next video.